So if we have to talk about resistor, you need to understand, let's say, Ohm's law, because we are defining the relationship between the voltage current and resistor, or we can say resistance. You need to understand the formula V equals I R. If you have any of these two, you'll find the value of each. If we were to find current, we'll have say I equals V over R. If we were to find the resistance, it's going to be R V over I. As you can see, these two are proportional to each other. When one goes up, the other goes down. When the other goes down, the one goes up. And we measure resistance in ohms. Symbol for ohms will be like that. We'll say 22 ohms, 100 ohms. So that's the basic thing that one needs to know when it comes to resistor. We measure them in ohms. When resistor goes up, current goes down. When resistor goes down, current goes up. The two are proportional to each other when you look at the Ohm's law. So in here, I just want to show you how a resistor is working as a current limiter. I've got a very simple, straightforward circuit. It's just an LED and a 12-volt supply. Then I have two resistors. I've got one in the high end and I've got one in the low end. I've got 47 ohm low and I've got 1K resistor in the high end. So what you will do, you're just going to see the difference of how the brightness of the LED is when we have low resistor and when we have high resistor. So I'm going to start with a 1K resistor. So as you can see, then I will do with a 47 ohm resistor. So as you can see, it gets very bright on a low resistor compared to when it's in high resistance. So I won't be explaining in details, but I just want to touch on the most basic fundamental when it comes to resistors. When you're doing your fault finding, if you look at my main channel, when I do fault finding, I'll measure across the circuit or across the board. I'll measure resistance. I'll see if the resistor is fine. I'll be looking for the right value of that resistor. So thank you so much for watching, and I hope you have a good one.